Okay, we will try to find the other way of finding the projection. It is minus 3.6 and 7.2. Okay, using other method. Other method starts with this actually. Okay, you have two vectors. This is u and this is v. Okay, let's draw the vectors exactly the way this is here. So this is the u vector. Okay, and this is the v vector. Okay, and we are trying to project u on v. So the projection will somewhere happen here. Okay, the u is shorter in length, so the projection might have happened somewhere here. What is the point here? It is minus 2, 4. What is the point here? It is 2, 10. Okay, so we are trying to project u on v. Okay, so this again forms one triangle. This is the position actually. All right. Okay. Now, what is this point? If this is like in x-axis, it is minus 2. Okay. In x-axis, it is minus 2, and y-axis, it is 4. Okay. Minus 2, comma. Let me go to this one. If we just extend this line, so this is minus 2 here, and this is 4 here. This is what this point says. Minus 2, 4. Okay, so now if you wanted to find the length of this vector, v vector, it is nothing but the magnitude of, that is the magnitude of v. It is nothing but, this is like a triangle. Okay, this is like c squared. Let's say this is the hypotenuse c. So c squared is equal to, let's say a squared plus b squared. So what it happens is, c squared, that is magnitude of v, it's equal to, magnitude of v is equal to c squared. I mean like minus 2 squared plus 4 squared, that is 4 plus 16. Okay. Square root of 4 plus 16. So magnitude of v is equal to square root of 20. So we just computed this magnitude of v. Okay, just keep it in mind. Okay. Now we have a relationship between dot product and this actually. So what is dot product? U dot v is equal to magnitude of u magnitude of v cos theta. Okay, that is the relationship between dot product and the projection. So what is u? What is v? This is u. This is u. This is v. This is u. This is v. Okay. So the same thing. So if we try to multiply the x with x and y with y, that is the dot product. Okay. X coordinate of u and x coordinate of v. So 2 into minus 2 is minus 4. Okay. Plus 10 into 4 is 40. This is equal to a projection of u on v in cos theta. There is one more concept. I'll just probably draw here. Okay, just to make it clear. If we have two vectors, let's say this is u vector and this is v vector. Okay, the same thing here. Just to this is the angle between the two vectors, and the projection it makes on the x-axis is called cos theta. Okay, and if it's a unit vector, the magnitude of u is 1. If it is not a unit vector, the magnitude of u becomes magnitude of u into cos theta. Okay, that's the projection it makes. So similarly, if you see, this is what we're trying to find. What is the projection u makes on v? These two is actually called as the projection of u on A. I mean projection of u on B. So these two together is called as projection of u on B, and that is called scalar projection, because we will just know the scalar quantity or the magnitude of the projection, but you will not know the intervector. Okay. So as you know, for defining a vector, you need to know the magnitude as well as direction. For example, in this case of vector u, we need to know the magnitude of u and also the direction, which means we need to know the value of I mean, you can find, if you give the value of x and y coordinates, you can find the magnitude of any vector, like we found it here. We have the magnitude of we found the magnitude of v by using the coordinates minus 2 and 4, and found the magnitude of the vector v. Okay. Similarly, we can if you this two put together, gives the projection in the direction of u, but it will not tell you the magnitude. I mean, it will tell you the magnitude, but not the vector direction actually. So let's see what happens actually. We call this as projection of u on v. Projection of u on v, these two together, multiplied by magnitude of v. Okay. So we're trying to find the projection of u on v. That is our objective. So let's call this as a projection vector. Okay. We wanted to find projection vector, that is projection of u on v. What we have is magnitude of v, that is square root of 20. And we have this value, that is 36. So projection vector is equal to square root of 36 divided by square root of 20. So we will not call it as projection vector, we'll just call it as projection because we don't know the direction of it. Okay, we just know the magnitude. So we call it as projection of u on v. Projection of u on v. So we are trying to find we have the magnitude actually, but we don't know the direction. Okay, which means that this u is projected on this, okay, along the direction somewhere here. Okay, we know the magnitude is this. Now we don't know exactly where the point lies. Okay, is it like we just have magnitude. It could be like here as well. It could be here as well. So we don't know. We cannot just judge what the value is. It is basically what if we just calculate this. It is just something like 8.6 or something. So we just know the magnitude. Okay, which we don't know the direction of it. So in order to find the direction of a vector on which the projection vector, okay, what we really need to know is, okay, we know that the projection somewhere happens on the vector v. Okay, so we can use the information from v and try to find out the projection vector actually. So we have one more vector, that is the projection vector p. That is what I'm trying to write here. We are trying to find the vector p. Okay, we now got the magnitude of p. Okay, now we wanted to find the direction as well. So for which we don't have any other information other than v. The one good thing is, since the projection will happen on the direction of v, we can try to use this v and try to find p vector. How do you find that? If you take the magnitude of v, if you take the vector v, okay, that is vector v is what? Okay, it is minus 2, 4. Okay, and if you find the unit vector of it, unit vector in the sense, it will give you a scaled down version of this vector, and that helps us to find the x and y coordinates of the unit vector of p. So what it really means is, we can take the vector v, okay, vector v, and find the unit vector of it. Unit vector is like this actually. So what is the unit vector is? You divide the coordinates with this magnitude. If you're able to divide the coordinates with this magnitude, then it is called unit vector. This coordinate is minus 2, magnitude is square root of 20. Okay, that's x coordinate. Similarly, the y coordinate, you can take 4 and divide by square root of 20. Now, if you divide the magnitude of this vector with its if you divide the coordinates of the vector with its magnitude, okay, the magnitude is square root of 20, which is nothing but this thing. This is what? This is square root of 20. Okay, you will get the unit vector. Now we know the projection. We know the magnitude of the projected vector. I mean, of the projection vector. We know the unit vector of the projection vector. So if we try to find multiply the magnitude of p vector with its direction of this unit vector. Okay, since the direction of the unit vector and the direction of the p vector are the same, we can use this actually. So we can actually find the original, the full information about this vector. So what it really means is, you can multiply 36 by square root of 20 with minus 2 comma square root of 20 and 4 comma square root of 20. If you multiply these two and you get x and y coordinates, it will be minus 3.6 comma 7.2. That is exactly what you get here. So this is another way of verifying the way we try to use matrix vector notations and try to get the solution. We can also use this formula, the relationship between the dot product, that is u dot v, and which is equivalent to the magnitude of u into v the cos theta. Okay, and we are trying to find the same thing here. So I'll just recap because it might be a little confusing. We have u, we have v. We wanted to find how u can be projected on v. Okay, we have information about v, that is some point in this line. That's the random point we chose in this line. Now, when we try to project u on v, we can you can use this formula actually. Projection of u on v. So u cos theta gives you the magnitude of it. Okay, that's what we're trying to find. The magnitude. U cos theta is actually the projection of u on v, and that's what we're trying to find. And we have the magnitude of v, and we're trying to find magnitude of v, and use this, substitute this, and this gives you the magnitude of the projection vector. Okay, this, and you get this. Then you wanted to find the direction of the projection vector. So we can leveraging the information from the vector v, and trying to find the unit vector of v, and multiplying the unit vector of v, which is equivalent to the direction, because both vectors probably point in the same direction because it is also projected in the same direction, right? So we are trying to kind of use this information. The direction of v vector is the same as the direction of p vector. So we are trying to kind of take the unit vector from v and make it and make it as a direction component of the projection vector. And if you multiply the magnitude of this projection, you get the same values, 3.6 and 7.2. This is another way of validating our findings. Okay. Yeah, just kind of revisit it one more time. Probably you will get it. Okay. So thank you.